Hey guys, today we're going to talk about a couple different kind of piecewise functions. The first kind we're going to start with is a step function, which is the one, if we looked at the special characteristics, let me get my pen. It's the one that looks like stair steps, which will make more sense in just a second when we graph it. Okay, you don't necessarily have an equation for this one. You can, but the one that we're going to work is coming from a word problem. So if I were to expand on it, it would say something like a school bus is needed so the student body can go somewhere, and we can only put 60 students per bus on. We can only put 60 students per bus. So how many buses would we need for a certain amount of students? Okay, so how this is, the equation is a little different. The table is much different. So let's look down here at our table. I've already kind of prepped it for us. So obviously if 0 kids are going, we will not need any buses. Okay, so we can go ahead and just graph that point right there. Okay, so no kids, no buses. But if we have x is greater than 0, which means we have more than no students going, but x is less than or equal to 60, we will need 1 bus. Okay, so what that looks like going from here to our graph. Okay, so if no one is going, we will not need a bus because that's already taken care of here. So from 0 to 60 kids, and remember, look over here, there's no equal to, so it is an open circle. This, there is an equal to, so it is a closed circle. Okay, so we get our closed circle here. So what this is saying is from like 1 to 60, we will need 1 bus. Okay, so I've already drawn it out here. If x is greater than 60, which means like you're at 61, or x is less than or equal to 120, we will need 2 buses. So we go up to 2. Remember, this doesn't have an equal to, so it is an open circle. This would be a closed circle connecting it. So you can see how this trend goes. Okay, so the next interval would need 3 buses. So open circle going over closed circle. Okay, notice this is a function. If it were to ask you, is this a function, you would say yes, because we can do our vertical line test. And how do we do that? Well, if I pull my pen across here, notice this looks like they overlap. However, this is a closed circle, which means it is included. This is an open circle, which means it is not included. So you only have one thing going on as you do your vertical line test. So let's try another one of these to clarify. Okay, all right, so let's think about like a cell phone plan. So if our cell phone plan told us that it was 45 cents per minute, okay, this one's a little more tricky. Okay, so we have 0 minutes, 1, 2, 3, 4, 5, 6, 7. Okay, I've already drawn out the graph over here as well, okay, or the chart. So if I have x is greater than 0, so I've talked on the phone at some point. Notice there's no equal sign, so it's going to be open. And then x is less than or equal to 1, which means that will be a closed circle. So my lines should look like this on my chart. Okay, so this is like 45 cents. So from 0 minutes, because if I don't talk, I don't get charged anything. So it's like 1 second starts it, to 1 minute, including that 1 minute, will cost me 45 cents. Okay, so I already have that here. So our next one would be 45 plus 45, which should give you 90. Okay, so if I look at that, okay, so I've already paid for my 1 minute, so like anything more than a minute to 2 minutes will cost me 90 cents. Okay, then I keep adding 45 cents, so this is like $1.35. Okay, so anything over 2 minutes to 3 minutes costs me $1.35. And then I would continue my chart this direction. So then you would have plus 45, which would give me $1.80. Okay, this is how it would look. Notice, again, this is a function. When the open circle and the closed circle make that work, because this one's closed, this one's open, there's no overlap on the vertical line test. I'll give you a couple more of these for you to work on your own. I'll attach those. Alright, so let's talk about one more kind of piecewise function. Okay, these are defined functions. So in your notes, the other ones are step functions. These are piecewise defined functions. Okay, they look totally different. Steps means it looks like steps. Okay, the defined look like you have two different, notice that we're going back to linear. Okay, so you have two different, two linear equations graphed on the same plane, but they start in a certain spot, which will make sense in just a second. Start in certain spot. Okay, so let's make sense out of that. So we're going to look, let me change colors for us here. We're going to look at just this top line first. Okay, so my equation is y equals negative 2x if x is greater than 1. So what this comment means is x has to be greater than 1. So when I am starting my table, x has to be greater than 1. So I would start with like 2, 3, 4, 5. Then I would just plug those in like we have. So 2 times negative 2 is negative 4. 3 times negative 2 is negative 6. 4 times negative 2 is negative 8. 5 times negative 2 is negative 10. Okay, so notice, going back to before, okay, this is greater than 0. So let's just take a side note. You will need to write this down somewhere. Okay, if it is greater than or less than, remember our circle is an open circle. If it's greater than or equal to or less than or equal to, we will have a closed circle, just like when we were doing inequalities. So you will need to go back and put 1 on there and do negative 2. That is our starting point. Okay, so we're going to go over 1 down negative 2. Notice it is going to be an open circle because it's not equal to. So that's my starting point. Then we graph the rest of them. 2, negative 4, 3, negative 6, 4, negative 8. Okay, and then my line will look like this. That's one of my functions. Okay, I am not done. Now, let me use a different color and go to our second equation. I'm going to take it down here for our chart. So our equation is y equals x plus 3, where x is less than or equal to 1. So this would mean it is a closed circle, but we have to start at 1. But notice it is less than or equal to 1. So all of my numbers in my graph should be less than or equal to 1. Okay, so we would have to go 0, negative 1, negative 2. Okay, so fill them in. Alright, 1 plus 3 is 4. 0 plus 3 is 3. Negative 1 plus 3 is 2. Negative 2 plus 3 is 1. Okay, so then remember, this one starts our equation. So it is less than or equal to, so we have a solid dot there. Okay, so we're going to go 1, 4, solid dot. Okay, then we're going to go 0, 3. This is just the dots that we're going to connect. Negative 1, 2, negative 2, 1. So then we have our line going in this direction. Now, what we have to say is this a function? Well, notice it covers vertical line. We're good, we're good. These will cross the same, should cross the same axis, or the same line, which is that 1 here. Okay, but this one's closed, this one's open, so it works because this hits vertical line 1 time. This one only does 1 time because this one's closed, this one's open. And then you continue and it only hits 1 time there. Okay? Alright, so let's try one more of these. Remember, we're writing all of these down in your journals. Okay? Alright, so we got 2 different things going on here. Let's start with this first one. It's like y equals 2x plus 1 if x is greater than 0. So when you're making your chart, okay, remember, we have to start at 0 because that's what it says, but x is greater than 0, which means we have to go up from 0. 0, 1, 2, 3, 4. Okay? So then we plug them in. 2x, 2 times 0 is 0 plus 1 is 1. 2 times 1 is 2 plus 1 is 3. 2 times 2 is 4 plus 1 is 5. 2 times 3 is 6 plus 1 is 7. 2 times 4 is 8 plus 1 is 9. Okay, now we got to go back right here. Is it greater than or equal to or just greater than? It's just greater than, so that means my circle is going to be open on that point. So we go 0, 1, open circle. 1, 3, 2, 5, 3, 7. We're going to stop right there because I don't have room. And connect it and then put an arrow on the end of it. That is our starting point. Now let's change colors here. We're going to go to the second equation. Okay? Alright, so making our chart, x and y, our equation is negative x. So if x is less than or equal to 0, so we got to start with 0, and it's less than or equal to, so numbers less than that. So we go to negative 1, negative 2, negative 3. And then we got to think x is less than or equal to, so we're going to have a closed circle there. Alright, so negative 0 is 0. Negative 1 makes this positive 1. And then you should get the opposite of all these because it's a negative x. Okay, so we have 0, 0. Notice, again, it is a solid circle. So at 0, 0, we have a solid circle. Negative 1, 1. Negative 2, 2. Negative 3, 3. Okay, and then we connect the dots, add our thing. Is it a function? Yes, because when we do our vertical line test, notice, open circle, closed circle on the same thing, which makes it work. Okay, remember this is a piecewise defined function. The other ones are piecewise step functions. Okay, I will add some of these for you to work on your own. Remember, both of these examples for both of these need to be in your journal for us to reference later. I will have a video of greatest integer functions coming to you, and that's the last of the functions. And then we'll learn how to take all of these, and you should be able to apply a rule now that you know what all of them look like. All right, have a nice day.